Welcome back to another YouTube Tuesday, where I go over a YouTube channel that you should definitely be following. On last week's video, there was a comment that I should review Edgar I Repair. He was already on my list, and he's definitely one you should subscribe to. Now, the channel that we're going to be looking at is his English version channel. That being said, his Spanish channel, he has over 366,000 subscribers and over 1,100 videos uploaded. So if you speak Spanish, the content there is solid. Now, I'm fluent in Spanish, which helps, but his English channel is phenomenal as well. There aren't a whole lot of videos, but I think with enough support, he'll make more content in English. That being said, let's take a look at one of his videos so that you can get an idea of why you should subscribe and why his content is so valuable.
Hello and welcome to another video. My name is Edgar and thank you for watching my videos, okay, and for all your comments. And remember, I'm trying to do my best to explain you these kind of repairs, okay? In this video, I'm going to try to teach you the step-by-step to fix an iPhone 12 Pro Max that come to my shop with no service, okay? So welcome to my channel. The first thing that...
So his English is actually pretty decent. You'll have to get used to the occasional word where it comes off with either a Spanish accent or said in the way you'd say it in Spanish. But it's easy to get past that because of the way that he breaks things down and makes things easy to watch.
You have to understand when you are fixing an iPhone that is no service or no email or no baseband or things like that. The first route is, or the first stage is logic part. The logic part means the baseband is talking with your CPU. That is so important because sometimes you have a problem with the baseband is just off, right? So you have to understand which lines you need to power on the baseband. And the second stage is analogic part. In the analogic part, you have the baseband talking with the CPU, but you have no service, or sometimes you don't have service with one company, or you have low service with some company. Some company you don't have, for example, 4G, you only have 3G, things like that, right? So it's two stage: analogic part and logic part. So you have to understand this before you are fixing iPhone with radio frequency problems, okay? So this phone, for example, I'm going to connect this phone, okay? The first thing we had to do is understand where is the problem, right? If it's the logic part means the baseband is talking, or it's a problem with the analogic part. The baseband is talking, but you don't have service, okay? So this is two different approach for this kind of repairs. So I'm going to connect this board to the flex cable. This is connecting to my power supply, and I'm going to connect the cable for trying to power on this phone, okay? And I'm going to open tres utools, okay? Tres utools. I'm going to connect this phone and we are going to wait, okay? So the phone is connecting, and the first thing you have to do is, see, we don't have email, okay? But that's not important. The important thing is you're going to come here, iDevice details, and you have to check for baseband version. The baseband version is the same thing of modem firmware. So if you don't have the baseband version, the number that is going there, if you don't have the baseband version, that means your baseband is off. Your baseband is just not talking with your CPU.
So one of the things that can cause this issue is a simple drop. Now, one of the most common things that I see is when a phone is dropped really hard, even if the back doesn't break, it can split the boards, and therefore you have no communication between the top board and the bottom board, so you won't have service. It could be a few other things, but that's one of the common things I see.
Understand this is a few steps that you had to follow before you separate the board. Never. This is the first mistake that some technicians do. They just come iPhone with no service and they take apart the boards and start trying to see if it's just bad connection or things like that in the interposer. And sometimes you make a lot of mistakes because you had to follow these some steps before you separate the board. Okay, so to understand this is, remember, you have a baseband, okay, and the baseband is off. Okay, right now it's off. The baseband needs to tag with the CPU, and to tag with the CPU is one lines here that we are going to call this line PCI lines. Okay, the PCI lines, and then the baseband, remember the baseband is a CPU for radio frequency, okay? So the baseband is going to have right here a PMU RF. And the PMU RF is the one are going to send the reels, the power lines, right? Power lines to power this baseband. We're going to call this one box or LDOs, right? And then also are going to have here another component, that WTR. And right now we have right here the front end. The front end, this is analogic part, okay? And the this one, the front end tag with the WTR and the WTR tag with the baseband. And this one we have antennas and all that kind of stuff, okay? To be clear, and then we also have right here an EEPROM, and we also have some clocks. Okay, some clocks, okay? This is some clocks that need the baseband to power on. So the first thing that we had to check before take apart the boards is we had to check if we have this voltage, because remember, the first thing that one circuit needs to power on is voltage, and then receive, for example, a power enable signal to start working and all that kind of stuff, right? But the first thing is we need voltage, so we had to check voltage. Okay, so voltage, remember, you can have voltage. Sometimes you are not going to have voltage because you have some line with a short circuit, or sometimes you are going to have a leak, right? Some leaking of current. So that's why you have voltage, but you don't have current. So that's another thing that we are going to learn later, because sometimes you can have the voltage, but you can't have the correct current to work this line. Okay, so where we had to check this voltage.
What he's talking about there is basically if there's a leak, that means that typically a secondary line or something that's attached to that is drawing power. And each line can work, in this case, can work within a tolerance. And so there are some lines that will have to be exactly the correct voltage in order to work. And there's others that have kind of a tolerance depending on what's happening, where it can have between a certain voltage and others. And so if there's a leak, it'll draw less, and so it won't actually turn on and won't boot. It's designed to switch on and off depending on whether or not it's sent the proper voltage.
Okay, so we're going to come here, and remember we have a PMU RF, right? The PMU RF, we have some lines that we're going to call box, okay? And then we have another lines right here that we're going to call LDOs. One tip that I'm going to give it to you is I just check the box. The box is the most important thing to check, okay? And I'm going to give you another tip. If we know where is the PMU RF, so we only had to follow the coils that are around the baseband. So for example, we have this coil right here, and don't click on the SW line. We had to click right here in the exit of the bug. If we click right here, this is a bug that have powered for the baseband, and also we are going to have one test point right here. Okay, and then we are going to have another bug, and we are going to have another test point right here, and then we are going to check this test point right here, and then another test point right here, right? And another test point right here, okay, 1.2 voltage, okay?
these test points are very convenient because it allows you to basically be able to test all of these lines that come off of that power management IC so that you can check and see if the proper voltage is going out without having to actually split the board and test. It's highly convenient to be able to know where to look to find these test points and use a multimeter to be able to determine if you have a faulty line that way or if you actually need to do more diagnosis with splitting the board and going that route.
And we have another one right here. So we have 5 voltage that needs to be present to have the baseband on, okay? So I'm going to come here. I already have the test point clear right here. So I already have this one. This is one. I have another one. I have this one. I have this one. And I have this one, okay? So we had to check if we have voltage there, okay? So I'm going to...
Now, if you didn't notice, he did scrape away. You take a razor blade and you just scrape away the black that's covering up the test points. You do have to expose these test points in order to be able to test them, but just scraping with the tip of a razor blade, you'll be easily able to remove that top coat and get to the actual test point with your multimeter probe.
I'm going to come with this. I'm going to put the ground. I'm going to put this one, okay? And I'm going to power on the fan. The fan is power on right now. We're just going to wait a little bit. Okay.
He's shorting between that data line on the power button connector and ground. By shorting it out, you're in a sense clicking or holding down the power button. It's the same function as the power button flex does, holding it down long enough for it to boot up. And if you watch your power supply, you'll be able to see if it's got a proper boot sequence to know that it's actually powering on.
Okay, so now it's power, okay? So I'm going to check right here. I'm going to put the multimeter and I'm going to check right here, okay? See, I'm going to check this line. We have 800 millivolts. I'm going to check this line. We have 900 millivolts. I'm going to check this one. We have 900 volts, 900 millivolts. I had to check this one. We have 1.9 and I had to check this one. See this one? This one? We don't have nothing. See, I have on this one like 900, 800, and this one, I don't have nothing, okay? This test point is for this line. Is for this line, okay? So this line, we need to have a voltage for around like 700 or 800 millivolts. But sometimes we don't know if we had to have voltage there because sometimes we are going to have lines that we don't have any power there until we put the SIM card, right? So that's why we had to have another board, okay, just to check if we had to have something there. So I'm going to power on this phone, okay, and see, we have 900 there. We have a voltage there, but then
it's always a good idea to have a completely functional board to reference so that you can double check before you go through all of this extra work if you find something that looks off. So that's why he has the second board, so he can compare and see is it actually supposed to have a value there, and in this case obviously it does.
Another board, we don't have any voltage, so be careful with this. And so we are missing one voltage and the bad board, okay? So if we don't have this voltage, the baseband is never going to power on. So we can have a problem there. We can have a short circuit, or sometimes we can just have a coil that is just with a bad solder there. So we have to check these coils. Or we can have a PMU that is not working, okay? So that's why it's so important. So we are going to do two things.
One of the things that I see a lot happen is those coils, they pop off. I see it a lot on iPads. Maybe it's because the iPad flexes a lot, but on like a hard drop on an iPhone, the coil can literally just pop away from the board. And then you won't have that literal wire that spirals around connecting the PMIC over to that buck line, so you won't have any conversion of power because the coil's literally popped off. So could easily be that. Let's see what he finds.
here. We are going to take apart the boards. I'm going to use this preheater, the Axiom. I'm going to leave the links on the description. So I'm going to use this one with a 220 and about like 4 minutes, okay? Because right in this area is small and I had the air condition, so sometimes it's just a little bit cold here, so that's why it take a little bit more time, okay? So I'm going to take this board apart. I'm going to check the PMU, and then we are going to check one more time, okay?
Now you can see there he went and separated them and he wicked them. Now this is completely, it's completely acceptable to do that. I wouldn't wick it personally if I didn't find that any of the pads were missing. If I found a pad was missing and I had to do a pad repair between the layers, then I would definitely be reballing the whole thing. But I like to be able to keep those spacers, and I have a technique that I show to be able to not have to reball it so that you can get a clean solder with being able to use the feature of that particular board heater that has these little clamps, so you can put pressure back down while the solder is melting and then cooling, so that you have a complete even sandwich by the time that you're done. But if you end up reballing, or if you like to reball, go for it.
Edgar, what happened? Why you restored this iPhone, okay? And to be clear with you, because I want you to give you my tips too, is very strange if the PMU is not working to send some lines, some power lines, but just one don't send this line, okay? So we have 4 voltage, but we are missing 1 voltage. So it's so difficult to the PMU to send 4 voltage and just 1 no. So that's why I separate the boards. I just clean the interposer and I just restore this phone just to try to see if just a bad solder in the interposer. And if you can see right now, this phone is activated, okay, and we have serial email right here, and also we are going to have the baseband version. Sometimes it's important to be clear, okay? Because we measure the voltage. Sometimes some technicians, they just take apart the board and they never know if they have voltage or not. So the first step, if you have an iPhone with no services, please check the voltage before you separate the board. In the next video, I'm going to show you how to measure the clocks, the PCI lines, and another lines with the WTR and the EEPROM. Okay. In this case, it's just a bad solder and the interposer, and we have this phone ready to go. I just had to put the boards together with the rebellion and all that kind of stuff. Okay.
So in this case, it was like I talked about at the beginning. The most common thing that I see is a phone to drop and the board split, and it causes that loss of power. So him basically taking it apart, reballing it, putting it back together is going to be the solution. The coil could have popped. I wonder if it was a coil too, because during the process of him heating it up, it could be that something resoldered on the coil itself. Who knows? But through a restore, he was able to get it working again, which is quite unique. But you could also see that he had it placed. He placed it inside of a clamping fixture that allows you to connect the top board to the bottom board through a pin system instead of a solder system, so that you can check and see if everything works. Run it through 3U tools, flash it, and obviously in this case he was able to restore it and get it to work. So that way he knew, yeah, in the end it was basically a cold joint due to most likely a drop between the top board and bottom board.
you please just subscribe and share this video with your friends, because we are going to learn a lot in this year. See you next time. Adios.
I've taken his advice and I've shared it with you, my friends. I highly recommend subscribing to him, and if you speak Spanish or don't, but you can, or maybe you don't speak Spanish but you want to learn more, I'm pretty sure you'll be able to at least understand the concepts and principles of his highly watched videos on his Spanish channel, Edgar I Repair. If there's a channel that you'd like to see me feature, leave it in the comments below. Thanks a ton for watching. We'll see you in the next video.